make sure that we understand this, I'm going to randomly call on a few of us to explain what these last four mean. And if you're not sure, then I'll let someone else respond, but that means I'm going to come back to you, so you better be ready. Jaden, can you tell us what that 48 means? No idea? Okay.
That's the freakiest.
So I'm going to go to somebody else, but Jaden's on you for the one after that, so pay attention to what they say. Jordan, you wanted to say it?
That's the frequency. Frequency. How you say it?
Frequency?
Yeah.
Frequency of what, though?
48.
Points.
48 points.
Okay,
Yeah.
Coda, add some more onto it.
48 frequency levels between 5 and 10.
Okay, that's a good start. Let's
Amazing.
clean that language up just a little bit. Emily.
The amount of lead went from 5 up to 10 48 times.
Okay, so the amount of lead concentration was between 5 and 10, 48 different times? Is that kind of what you're saying?
I basically said that.
It was close. I will say it this way. I'm going to clean it up just a little bit more. There were 48 data points that had lead concentrations between 5 and 10 parts per billion. There were 48 data points that had between 5 and 10 parts per billion for their lead concentration. All right, Jay, coming back to you. What does this 100 mean? Okay, what frequency? Frequency of what? Jay, you know I just said the 48 2 times in a row, right? Did you hear that, or were you distracted by Ethan?
I was right.
Okay, pause for a second. Can someone tell us, someone I haven't heard from, what the 100 is? Barry Lee?
How many data points have lead concentration between 10 and 15?
Okay, so how many data points had lead concentrations between 10 and 15?
100.
Jay, did you hear what he said? Dog. I'm literally telling you that I'm going to come back to you when someone else says it. Listen to the man. Barry Lee, can you say that one more time?
There were 100 data points with a lead concentration between 10 and 15
Parts per billion.
parts per billion.
There you go. So what does this 47 mean? Jane?
Write it down.
It like legitimately, can you write it down as he's saying it?
You gotta say this.
So I will write down what Barry Lee said. Barry Lee said there are 100 data points with lead concentration between 10 and 15 parts per billion. Write that down if you were not sure what he said. I will wait for you, Jaden. We are waiting for you on the 47, so write that down quickly. Are you all prepared to talk about this? No? Then why aren't you writing this down? If you want to ask a question, ask a question. Why are you scared?
Just say it.
Literally, guys, I need y'all to understand. There is literally a part of your daily grade that comes down to you being willing to ask a question in a whole class group discussion. Ask a question. No, there's no never mind. Ask your question. There's probably people who have the same question. Step up. Ask it.
I'm trying to put the list together. It won't sound right. It sounds better in my head.
Then try to get out there. Guys, I need y'all to hear me very clearly on this. You want to know how you get better at talking?
Communicate.
You do it, but you do it more often. You literally get better at talking in front of people. You get better at putting your ideas together when you do it more often. That's why I'm comfortable teaching in front of a class. And even still, I stumble over my words some. So stop being scared, guys. I'm not going to ridicule anyone for stumbling over the words or struggling with it. I'm going to help support you to get better. That's why I say, hey, does anyone want to add on to that? Listen to how someone adds on or improves it, and learn from that. What did you want to say?
So for the next one, is it, okay. For the next one, is it like the frequency of 47, of lead concentration is a 15 up to 20?
So the frequency of, and so notice the way we said it right here. So you're saying that that frequency of 47, that means there's 47 what? Data points that have what?
That have lead concentration
Lead concentrations.
between 15 and 20.
A little bit more. What's the unit? Parts per billion. All right, Jaden, we only have one more, so it's your time to shine, bro.
Come on now. I believe you.
So this is 23 right here. Tell us what that 23 is. I need y'all to be quiet and be respectful and listen.
You got to.
Hey, Jaden, I'm going to tell you this very clearly. Have you written this down right here? Yeah? So, I want you to understand, what are the first two words you're going to say? Okay, there are what? Close. Look at that number again.
22 data points with lead concentration between 20 and 25. Or up to 20 up to 20.
You're right. Yeah.
20 up to 25.
25 what? Just one detail.
PBB.
Dog, like this is what I'm saying. You crushed that. You had a little stumble, but all you had to do was use the format in front of you. Y'all making this harder than it has to be. Use your notes, use your resources to be successful. This is why I write crap on the board. Write it down. Use your notes. And you don't have to be perfect at it. Just like I helped Maddie, just like I helped Jaden, I'll help you improve your ability to say it. The only thing that's going to ever frustrate me is you sitting there like you're too cool for school. Because I'm going to tell you right here and right now, you got to do some work for my class. You can't sit there silent the whole time. And there's quite a few that I'm looking around and I'm seeing that I have not heard from at much or at all today. If you're the silent one, you got to step up. So, we're only going to get to talking or graphing a histogram. Again, please be aware I'm going to use this term. The bin are these values. The bin is an interval of values that the data point could fall into. So I don't know the exact lead concentration. I just know that there are 32 data points that had lead concentrations between 0 and 5. That's the bin, 0 to 5. Thomas, what's this bin? There we go. That's what a bin is. That's it. Okay? So a way to display quantitative data is to create a histogram. A histogram is a graphical way to display quantitative data, which we haven't used this word quantitative. What type of data have we called this? No, type of data. What are the two types of data? Categorical and numerical. Lead concentration, was it categorical or numerical? It was numerical. So another word for quantitative, that's what the book's using, that's numerical. Anytime you see quantitative, that's another word for numerical. If you didn't know that, that's a note I would make to myself. Quantitative is another word for numerical. And so from there, notice the width of the bar in a histogram represents an interval of data. So what's the width of my first bar going to be? So notice that width matches the bin. The width of your bars match the bin. Okay? Now, I want to point this out. Have y'all done graphs with bars in them before? What did y'all used to call them?
Bar graphs.
Bar graphs. Those are different than histograms. Whenever you did a bar graph, weren't the bars separated from each other? Because bar graphs go with categorical data. And so you have the categories separated. Bar graphs go with categorical data, so the bars are separated. Histograms, isn't that 5 right next to this 5? Okay? So you're not going to separate the bars with histograms. Make that note. Do not separate bars in histograms. You're going to keep those bars together. Okay. So what do you think I'm going to need to construct this histogram? What do I need to draw? A what? Where do you get the square from?
Oh, I thought that was
I don't have a histogram yet. The histogram is the graph. Typically, what do we need for those kind of graphs?
Quadrant.
Lines, quadrants. So what are the lines that separate the quadrants?
Axis.
I might need some axes, right?
Yeah, the action and the Y.
Okay, so I'm going to draw some axes here. All right. What do you think is supposed to go on the x-axis, and what do you think is going to go on the y-axis?
The frequency on the bottom one and the amount on the top one.
Okay, so you're thinking the amount of lead on the y-axis and the frequency on the x-axis? Okay, but so let me ask you all this. How high are we going to go with the bar? What tells us how high the bar is?
the frequency.
The frequency tells us how high it goes, right? And how high is going to match the...
X. Or the Y.
Isn't the y-axis measuring how high it goes? So the y-axis is always going to be your frequency on a histogram. Sometimes it's a relative frequency, but for the most part, at least in this class, the y-axis is always going to be my frequency. Notice the bins are always going to be on which axis?
X.
The x. Your bins are always going to be on the x-axis. Now, I'm not going to label it bins. These numbers are referring to the what?
Amount of lead in the water.
Right. Notice how this kind of matches the idea of a table, x and y? That's why it's set up like that. X-axis, y-axis. So, amount of lead.
Breaking down.
In water in parts per billion.
I'm going on.
Okay. Now that I have my axes labeled, hold on one second, Cody. You're going to want to move frequency off the y-axis so you can put the lines there for the numbers. Does that make sense? Guys, if you haven't noticed that, I've left space between my labels and the axes so that I can mark lines for the numbers to be put in there. Because what numbers need to go on the x-axis for the amount of lead? The what?
The frequency.
Well, but notice I need to go up to 25. But remember, do I need 1, 2, 3, and 4? I only need
Up to 5.
0 and 5. And then the next one is from 5 to... So I'm going to go 0. And then the first mark is going to be what?
5.
What's the next mark?
10.
And I'm going to try to make sure that my bins are the same length because, well, 0 to 5 and 5 to 10 are the same. And then 15. Woo! Good job, guys. After 15, I have 20. And after 20,
25.
right?
Where's space came out like a bunch?
Say again.
When spaces came out like
Not a bunch. They just need to be about the same. Is the big thing, right? So your bins need to be about the same length all the way through. Okay? How high does my frequency need to go?
Up to 100?
Needs to go up to 100? What scale do you think I should use looking at those to be able to get up to 100?
10?
Ooh. If I go by fives, how many lines do I need to draw? 20, right? 20 times 5? What might be easier?
10.
10s? Maybe 20s, but I'd probably go with 10s. Right? Notice that I'm not saying you have to go with 10s, but I am saying if you're going to go up to 100, then you want to use something that's easy. 50 would be way too much. 20 you can probably get away with. 10 is going to give you more accurate view of things. And again, since I'm going every 10, I need to do about the same value every single time. Now, I do want to point this out. This is just a blank sheet of paper which can make accuracy tough. What can you get that might make it easier to draw a graph like this? Graph paper. Not saying you have to. I have some graph paper somewhere, and I'll get it out in the future, but just use this to draw an approximation. And if you have to just extend it up above the line, you can. Notice it's not perfect, but have I roughly gone the same distance every time? Yeah. Right? Again, it doesn't have to be perfect. I'm not an artist. It just needs to make sense. So now what's the height going to be for 0 to 5? 32. So I'm going to go just a little bit above 30. And I'm going to draw a little bar there. There we go. So there's my bar. Not perfect, but is it believable? Okay. Hey Trent, Tamarlin, how much of this have you drawn on your paper? You got those bars up there? That bar that I just drew? Dog, seriously? And I'm pretty sure that graph that you have is not going to help you a ton because it's not very accurate. That's just barely above 20. That can't be 32. Guys, I'm going to be looking for accuracy with your graphs. We have a frequency of 32 here. Take your time. Put pride into your work. Your education matters. All right, so how high does the bin from 5 to 10 need to go? 48. So I'm just going to go a little bit below the 50. Might make a note there. Okay, so again, I can't do this by hand perfectly, but it's pretty darn close. Yeah, 5 to 10. The bin 5 to 10 has a frequency of 48. Okay? 10 to 15. That's the good old 100, so I'm going to take it all the way to the top. $15 to 20.
47.
Right, so right about the same place as the 2 bars ago. And 20 to 25. 23. So just a little bit above. And again, I'm just estimating. So, hold on. I wanted to point this out, and I want to pause for a second. There are 250 data points that we just represented. As a dot plot, how many points would you have had to draw?
250.
250. Is that easier than doing 250 dots?
Yes.
This is why we want to know about histograms, because it's going to make our job easier to represent that data. Can you see the shape of that data pretty well?
Yes.
Yes. Just out of curiosity, anybody want to take a guess roughly what the center of that data might be?
100.
Say again. So remember, 100 is the frequency, it's not the actual values, right? But the center might be somewhere in here, meaning that it's between 10 and 15.
13.
10 to 15?
You say
Yeah, like
13?
it's good in the middle. 10.
But we don't know exactly, here's the thing. Do you know exactly what the values are for those 100? No. We only know it's between 10 and 15. They could all be 11. We don't know. They could all be 14. Well, it could be. I just don't know what those individual values are. Remember, I only have frequencies for that bin. I don't know the exact values. Guys, I don't know why any of you think you can pack up right now. 3.5 minutes left? You must be outside your mind. I'm going to teach from bell to bell. We don't pack up before I say pack up. Y'all need to get used to this. You're in high school, not middle school. What you got? Some of us may be in high school, we haven't acted like it.
I would have been here about what?
Huh? I said you may have been.
About a week.
Oh, okay. So, what are your questions about this histogram concept and how to graph them before we wrap up for today? Nathan?
I was getting confused with the frequency. Like if you 0 up to 5 and there's 32. I was confused, like how did anybody get 32 with that?
So we don't see the actual data. They're telling us that, so like what happened was the mayor of Greenville wanted to analyze the lead levels. So he has 250 data points. Do you want to look at all 250 data points? No. So someone else already did it and told us that there were 32 of those data points that had lead levels between 0 and 5. Why are you still packing, Brooklyn? I haven't said to pack yet.
Oh, okay.
Okay? Someone told us that. Joey, what you got?
I'm not really good at doing graphs, so mine doesn't really make a lot of sense.
I don't care how good you are at it, let's get better at it. You don't have to be perfect, I just need you to work to get better. Okay? It's all about growth.
Yes, sir.
Alright? So from there,
High stuff, high stuff.
alright, we're going to come back and finish this on Monday. Yeah, we're nowhere close to this.
High stuff, high stuff.
Excuse me! I'm into the closing slide. You can wait 30 more seconds. So I mentioned this yesterday. This practice, we didn't get a chance to get to 3, 2, 1. This practice assignment, I was planning on making it due Tuesday. Go ahead and make a note to yourself. It'll be due on Wednesday. Just based on where we are, I'm not going to rush Monday to make sure you can do it on Tuesday. But if you know that it's due on Wednesday, we're going to cover the majority of what you need to do that assignment Monday. That means you have Monday night and Tuesday night to get that assignment done. Plan accordingly. This assignment right here, to help you practice and get better at these skills, is due when? Wednesday. So how many nights do you have to really get it done?
Line.
Monday and Tuesday. So it was due on Tuesday. Right, we could notice, how many pages have we got through? I made the entire lesson. 2. You haven't finished this. Okay, we haven't gotten. Excuse me, that bell hasn't rung. Get your butts back inside this room. There you go.